Hi, here we go. Let's try to go through quiz 2. Again, there are 5 different quizzes, so let me take a look at commonly missed questions from Khan Academy. Quiz 2. When I look at this report, it looks like 3 people missed question number 2. They're asking you to give the value of the integral from -2 to 3. The function, the lines are all underneath the x-axis. So first of all, these answers here ought to be negative. The next thing that you want to do is find the area using a rectangle and a triangle. The way that I see it, I'll go ahead and see if I can draw directly on the problem itself, which I can't, but then I'll work over here. So I'm looking at when x is -2, and I'm working all the way until x is +3. So -1, 0, 1, 2, 3, something like that. Sorry if I'm not that accurate. But what I see when I look at these lines is that there's this rectangular section right here going from -2 to 3. And so the area that would just be a rectangle that's 1 unit down and 5 units across. So that's -5. Ooh, this is not good drawing. Hopefully you can see it off to the side. So anyway, the area that first rectangle is 5, but I'm going to say -5 because an integral can be negative whenever the function's underneath the x-axis. Then finally, I see this little section that is a right triangle if I am stopping where x is -3. So that's going from 1 to 3 on the x-axis. So this distance right here would be 2. And then it's going from 1 to -4 on the y-axis. So that distance right there would be 3. And so if I do a base times height divided by 2, then that area is going to be 3. But again, since it is under the x-axis, then that's -3. Add those together, and it's a -8. Now, one student did say 8, and so the only thing that was off about that is that it's -8. Again, take a look at these hints. That is the first question that was missed by 3 students on the first attempt. Here's another question that is asking to evaluate h of 3, and h at the top of the screen here is the integral starting at -4. And so what you see inside the parentheses is where they would like you to close, where they want you to stop and form that shape. So if I am, I'll sketch this one out on binder paper here. If I'm at a constant of 8, and the first x value is going to create my area here, then my x value is at -4. And then I'm going to continue on until when x is 3. And so you see once x is 1, that there's a line that's dropping down and it is stopping at 4. So my sketch is not good. But hopefully you hear me kind of talking here, and I'll show you what my sketch looks like in a second. And then so it stops there at 3. So you see that it goes constant a y value of 4, but that's after the fact, right? So if I'm trying to look at what this shape is, it appears to be a 1, 2, 3, 4, 5-sided shape. But how I'm going to calculate the area is I'm going to do, oh, they've got the area right here on the screen. Much better than my drawing. So you're going to find the area of this trapezoid right here. And so the trapezoid goes from when y is 4 to when y is 8. The lower base of the trapezoid 7, because you're going to go 7 across, right? The other base of the trapezoid is going to go from -4 to 1, so that's 5. And so you see in Khan Academy's hints, they found the area of a large rectangle, subtracted a right triangle. What I would probably do is find the area of the rectangle at the bottom. That would be base of 7, height of 4. And then add on the area of a trapezoid. And so that's 1/2 base of 7. The upper base is 5. And then the height of that trapezoid is going from 4 to 8 on the y-axis. And so that's 2 times 12, and that's 24. And so 28 and 24 is going to give you that same area that they got, which is 52. So I'll just share what it was I was saying. I was writing it down as I was talking. So I did a rectangle and a trapezoid, and I'm still going to get that same answer. Again, when we first started learning area or integrals, we understood it as area. And to calculate an integral without using an antiderivative, coming up with the function f, you just want to cut the shape up into familiar formulas that you have. Let's look at the third question. Now this is, I'll write this one out. So this one is the fundamental theorem of calculus. Notice that they define the function capital F as the integral, and the upper bound is x to the third, and then the function that you're integrating is sine t. And so the question is, what is f prime of x? And you see the answer over here on the right, but let me talk through it here. And so the first thing to note is what they've defined and what they're asking is different, because this has a derivative, you know, that little prime symbol. And so something that is good for you to always pause and say, well, if this is the function and they want the derivative, and this is what's called an antiderivative, and I take the derivative of the antiderivative, the things are going to cancel. However, that's only true when I'm going from a constant to x. So if this is a function of x, it's like using the chain rule, where there's a function inside of your function. If the integral is a function, x to the third is the inner function. So there is some inversing happening. You are taking the derivative of an antiderivative, and so you'll see that the sine function is going to be part of your answer, but it'll be f of g of x, right? So you'll do the sine of the inner function, and then you have to multiply times the derivative of the inner function. And so that is the correct response to that one here. 3x squared, right? X cubed. 3x squared times sine x cubed. Let's take a look at the next question. That was missed by 2 people. And you're going from -4 to -1. And so on the right side here, where I'm showing the hints that you could have been given, you're looking at needing to find the area of a rectangle with a little right triangle on top. So that's 3 units wide, 5 units up, that's 15. And then the area of the triangle is just 1/2 of 1 times 3. So 15 plus another 1.5. Let's do a few more here. So the next question has a graph of f, and then you have the integral defined as the g function is the integral starting at 0 to x. What's an appropriate calculus-based justification for the fact that g must have a relative minimum? In order for g to have a relative minimum, the derivative must change from negative to positive. So g is the function. The derivative of g is f, because the derivative of an antiderivative is just kind of inverse itself. So the reason why g would have a minimum is because f is changing. Let me take a look at, you see the hints hopefully over here on the right. Again, you can always see those hints if you don't know how to answer a question. Just look at all the hints and then try to figure it out. And just by, you know, but in a couple of days, hopefully you'll do really good on the unit exam. And so the f crosses the x-axis from below and above it is the correct answer on that one. You can see over here on the hints, it shows what the correct answer is on the bottom. Let's do a couple more. 7 and 13. How many times have I said let's do a couple more? Let's do 3 more. So the graph of f is given with the area of each region shown. Again, the pink is they show a 6, but it's negative because it's underneath. So the question is asking, what is the integral from 0 to 4 plus 4 to 6? And they don't show 4 on the x-axis as an intersection point. of the function, but if I go from 0 to 4 and then from 4 to 6, it's the same as the integral from 0 to 6, which is what they're showing over here on the hint, 3 of 4 hints, right? So 5 subtract 6 is what you're going to need to do to calculate what that integral is. 2 more. The graph of f is being shown. G is a function defined as the integral of that, so the area from the curve up to the x-axis. What's a appropriate calculus-based justification for the fact that G is concave down? So if I have G of x, G prime of x tells me whether G is increasing or decreasing. And then G double prime of x is going to tell me whether G is concave up or down. And so if G is equal to the integral of f, writing and talking at the same time. So if G is equal to this integral, G prime would just be f, because the derivative of an antiderivative is going to inverse that function. And so G double prime would be f prime of x. So now I'm looking at the slope of this f function, and the reason why it would be concave down is because f prime is decreasing. It's because f is decreasing, f prime is negative. So let me take you back to the question on Khan Academy. What's an appropriate calculus-based? G prime is f, G double prime is f prime is decreasing, would be f prime is negative is the same as f is decreasing, so the correct answer choice is B. Let's do one more. Okay, so this one again is the fundamental theorem of calculus. Better than the last one, we don't have to use the chain rule. So the derivative of an antiderivative is just going to be the function itself. And so that's negative 2t plus 4. And I would sub in a 3. And so the answer is 10 again. I feel like I'm explaining what's on the right here, so please let me know if you want me to keep doing these. Again, this was quiz 2, and you want to get through 5 quizzes. There's quite a lot of information that you covered this year. You want to make sure that it's fresh in your mind. So again, thank you. I hope you're watching, and if you want me to continue, why don't you send me an email? Maybe if these little videos are helpful, I can jump in and do quizzes 3, 4, and 5 for you by the end of the night. Look for an update from College Board. I'm going to tune in tomorrow night, and I'll probably give you an update Wednesday. Have a good day.